Okay, let me check if this works. Okay, we are officially live. So, hello everyone. Welcome to the 50th community call. I'm Robert, a developer advocate at the Starknet Foundation, and I will be your host for today. We're delighted to have Ariel as our invited speaker for this session. Ariel is the product manager and blockchain researcher at Starkware. Our focus for today's discussion is Starknet version 0.13, covering topics such as reduction in transaction fees, Cairo 2.4.0, and version 3 transactions. For our viewers, if you have any questions, feel free to drop them in the YouTube chat section, and we'll try our best to address them. Welcome, Ariel. I'm super excited about this session and eager to learn more about Starknet version 0.13. Ariel, the stage
Thank you.
is yours.
Hello. So I'll just share my screen. Uh, right. So you should be able to see my screen now, correct?
That's correct.
Okay, amazing. So O13, whoa, yay. This is the first version where we introduce paying with Stark tokens and Starknet getting a native token, which we will discuss only at a technical level. So please don't ask me money questions because I won't have answers anyway. But we'll talk about the tech stuff in Starknet, which is always nice. Okay, so v0.13. What have we got? v3 transactions, which we'll talk about in more details in a few minutes. Payment with the Stark token, Cairo 2.4, and reduced transaction costs. So all really nice things, and let's jump into them. Robert, please ping me if there are any questions in writing because I won't see them.
Will do.
Okay, cool. Okay, so V3 transactions, what's new / special about them? First of all, so far, every transaction specified max fee in ETH units, actually way. And with V3 transactions, max fee is replaced by max price per unit and max amount, which is more future compatible for the point in time where the protocol actually has a fee mechanism and you're able to actually propose a tip per unit of computation. So with max fee, there is not a lot of wiggle room. So V3 transactions take that into account. We are separating L1 resources and L2 resources. So shortly, I'll dive more into that, but essentially every Starknet transaction has two types of resources associated with it. One is L1 resources. Whenever I submit a transaction, I eventually need to prove it. This proving on L1 has some costs measured in L1 gas. And in addition to proving, there is also the data availability cost of the transaction, which I'll also discuss. So all these costs of the transactions are measured in L1 gas. But on the other side, there are stuff like sequencing costs. You actually need the sequencer to include your transaction, execute it, and all those type of things go into the L2 gas category. In O13, it is not in use yet. We still did not define L2 gas, but in order to keep future compatibility, we introduced it to the transaction structure. So once we do define it, it's easy to use the existing transaction in order to split resources between L1 and L2. Okay. In addition to L1 and L2 gas, we have a bunch of new fields. And these are all placeholders for features that we are going to add to the protocol in the upcoming versions. First of all, tip, critical for having a meaningful fee mechanism. Tip is the only way to express your desire to be included in a block more quickly than others. Max fee today does not give you this flexibility. volition fields. Volition is Starknet's way to reduce the costs of data availability significantly. Obviously, we are in line with Ethereum's roadmap on this, which is EIP 4844, which will also significantly reduce data availability costs. But volition can further reduce them for those who want a data availability mechanism which is completely independent from L1. And these volition fields, fee data availability mode and nonce data availability mode, allow you to say, hey, my nonce and my balance, please take them from the off-chain state rather than the on-chain state. Because today, whenever you submit a transaction, there is a minimal cost that is induced by bumping your nonce and reducing your balance due to fees. These are two separate state changes. Every state change must reach L1 as call data. This is how it works since we're a rollup. And this already adds something like 1 to 2K minimal gas costs for your transaction. So hopefully with this, we'll be able to get it near zero. Paymaster data, allowing for someone else to pay with the native token for your transaction and allowing you to pay with different tokens. And account deployment data, which allows you to bundle the account deployment and the first operation in a single transaction. So currently, how it usually works in Starknet is that the user, the wallet actually, not the user, the wallet determines the account address off-chain, holds on to the deploy account transaction until the user wants to do the first operation. And once you want to, for example, transfer funds, then the deploy account and the transfer transaction are sent to the network by the wallet. So this will allow the wallet to bundle those in a single transaction. Yes, so none of these are related to O13. These are just placeholders for future versions, but it tells you what we have in store for Starknet. Yeah, so these are V3 transactions, and probably the most important detail about them, they pay with Stark. So older transaction versions always pay with ETH or Wei, and V3 transactions always pay with Stark or Phi, which is like Wei to ETH, 10 to the minus 18 Stark. And for those wondering, Phi stands for the very concise name of Fast Reed Solomon Interactive Oracle Proofs of Proximity. So that's a single Phi. Okay, any questions, comments on V3 transactions so far?
I believe there was one question, and basically regarding the payment in Stark token, and that means that can we choose between Stark and ETH, or is by default Stark?
So you can't choose it in a single transaction. V2 and prior transactions always pay with ETH. V3 transactions always pays with Stark, and gradually, as the ecosystem converges to this new change, then the older transaction versions will cease to be supported eventually. For now, they are all still active, but eventually Stark will be the token in which fees are paid. But there is no choice within a single transaction. Either you are V3 and you pay with Starks, or you are V1 or V2 and you pay with ETH.
Awesome, thank you. That's it for now.
Okay, great. Okay, so the Stark token, what can we say about it, and why do it? Why go down this route anyway? So recall what I said in the beginning, that L2 Starknet transactions have two types of resources, L1 and L2, and it's kind of weird to pay for L2 block space in a token whose utility is L1 block space. Gas and ETH, which is used to pay for gas, is very much associated with the ability to be included in an Ethereum block, which makes sense when I want to pay for the L1 signature of a Starknet transaction. Okay, when I want to pay for the proving cost of a transaction, it makes sense that I pay with ETH because this is a gas cost, this is an L1 cost. But when I want to pay for the sequencer, who's getting different proposals on from transactions that want to be included in an L2 block, it's weird to couple that with the token that that is responsible for L1 block space. So yeah, broke, pay L2 fees with an L1 token, woke, pay L2 fees with Starks. Okay, so more about L1 and L2 resources. It's important to note that today we completely neglect the right-hand side. All costs of a transaction, even V3 transactions, is only measured on the left. We only take into account L1 resources at this point in time, including version 0.13. And the L1 resources consists of two major parts. Posting state diffs to L1. Today, we use call data for that. After 4844, we'll use blob data. So whenever your transaction updates a storage cell, this diff, the key and the new value, goes to Ethereum as call data. And the second component of the L1 resources is the proof verification cost. Okay, so these two together comprise the L1 resources of the transaction. And on the other hand, we have the L2 resources, which are neglected as of now, but in the future will be associated with L2 gas. And these are the sequencing costs. These are the costs for computation on L2, for call data on L2, and for storage on L2. So in the future, this will be the more dominant cost in the system, because proving costs essentially raises logarithmically with the throughput, while this cost raise goes up linearly. And eventually, we imagine that the dominant factor for the cost will be congestion in the network, will be L2 congestion. A lot of people want to get into a block. There is some NFT minting, there is some contract to inscribe to, there is some DeFi to do, there is some any one of the numerous degen activities you want to do, and this eventually means you have to compete on L2 block space. Okay, so again, today we only price for the left, in the future for the second one, and for the second one, it makes sense to not couple the costs with the unit that pays for L1 gas. For the left side, it makes a lot of sense to pay with ETH, which is what's being done, prior to V3. Okay. Any questions?
So far, so good.
Okay, cool. So what I said now raises a question, because if we're only charging for the left-hand side and the left-hand side is priced in ETH, how are V3 transactions paying with Starks? Okay, so the answer to this is an ETH Stark oracle. So the sequencer will need to know the ratio between ETH and Stark. And the way he will do it is by using some ETH to Stark oracle. So he will have to price L1 gas in Starks. And the way he will do it is by asking, relying on oracle feeds. Okay, so it's important to note that only the sequencer takes a risk here, because from the user point of view, he's signing on some max fee per unit, and he doesn't care about the volatility of the oracle and that sort of stuff. This can almost be viewed as hedging on the sequencer level. If the price is too low, then the sequencer will lose funds. If the price is too high, then the user that wants to send the transaction from the wallet will see the high estimate and refuse to sign until prices go back to normal, which is the same experience that exists today. And just as a silly example, let's say the oracle tells us one ETH is 10 Starks, and the L1 cost of the transaction is 1K gas, and the gas prices are 100 gwei, then the price for the transaction is obviously 1K gas times the gas price, which is 100 gwei, so 100 to times 10 to the power of minus 9, times 10, because 1 ETH is 10 Starks, which ends up with 0.01 Starks. So a very silly example, but just to demonstrate what the sequencer will do. So this is how we cope with the challenge of paying for L1 resources with Starks. Obviously, when we start focusing more about this type of resource, then we won't have the same problem. We need the oracle here because L1 resources are inherent to L2 transactions. You're changing the storage, you need to post state diffs on L1s. This means you have some associated L1 costs that you need to handle. So you must do the conversion somehow. Okay, so this is the ETH to Stark oracle story. Questions before I move on to speak a little bit about Cairo?
Yes, there's actually just one question that seems interesting. So basically on Twitter, Panda is asking, so the Stark we pay will be calculated based on the fee we're gonna pay using ETH?
Yes.
And that, okay, that's it.
Your Stark balance will be changed, your ETH balance will remain unchanged, but the amount that you will pay will be determined by L1 gas costs and conversion between ETHs and Starks, yes.
Awesome, thank you.
Okay. So not a lot to be said about Cairo. You should read this post, which I will very quickly go over, but it really dives into the changes in the new version. So I'll just show you briefly what you are missing. First of all, long strings, probably the oldest request in Cairo since the days of Cairo 0. So far, we only had short strings, which were limited to 31 characters. So old enough Cairo developers have developed the ability to estimate visually whether or not a string is longer than 31 characters. I think that's about something like this. Maybe not. But people in the ecosystem long enough can basically look at a string and tell you whether or not it surpasses 31 characters. So no more. With the string literals, you no longer have to care about it. We have the new byte array type, and you can do all the string formatting that you can do in Rust. So very nice stuff. Still missing from byte arrays is the ability to store byte arrays or strings in the contract storage. But this, I think, will very soon be merged on main, which means that if you're using Scarb nightly, you will soon already be able to store strings and not have to wait to the next Cairo version. Yeah, so these are byte arrays and strings. A bunch of string-related macros. I won't really dive into them. Again, the post really goes into it. There's a new Sierra version, which is the reason we're even discussing this. The protocol knows the Sierra version. The protocol does not care about high-level Cairo. What the sequencer needs to know is how to compile Sierra down to Cairo assembly. remember that Sierra is what is actually being sent to the sequencer and not Cairo. You compile from Cairo to Sierra in your home and submit Sierra to the sequencer. So we've upgraded Sierra. I won't dive into it, but I will just say that there's a very nice mechanism in Sierra to dynamically count the amount of gas being used by the program. It used to depend on linear programming, which made the whole thing not really stable. And now we have a much more straightforward algorithm to compute the gas usage of the program, which is very nice. This is still not used in production, but it solves many compilation issues which were brought on the compiler repository. So very nice. Yeah, and if anyone has a concrete question about Cairo 2.4, then feel free to ask. There's also the Cairo 1 Discord.
Definitely. Yeah. I believe I'm super excited about this version, mainly because the introduction of the new macros. I think those are very interesting to see, especially the format, the print macro, things like this. But also, I believe the anticipated, feature, the long strings with the byte 31 and byte array. I think that has been anticipated quite a long time ago. So super excited about this version.
Yeah, with the new implementation of store for byte array, I think this pretty much closes this long-standing issue of long strings. And I assume this will be incorporated in standard implementations of ERC 721 and the like.
Awesome.
Okay, cool. So these were strings and byte array. So we're coming to the last thing in this version, which is cost reduction. So transaction fees are going to drop rather significantly. So in a few points, I want to go over what exactly is being improved. Maybe I should start with the second point. So computation is 50% cheaper. All across the board, the price of a single Cairo step is reduced by a factor of 2x. So if your contract is computationally heavy, then you're very happy about it. You are now paying 50% less fees. And on top of this, there are very concrete operations that were optimized by roughly 35%, which is the SecP multiplication. These functions are used for either verifying Ethereum signatures or verifying enclave signatures. So very important if your account is facial recognition based. If your account is facial recognition based, then under the hood, you're not using the regular Stark signature. You're using SecP R1 ECDSA. So this is a cost you pay in every single transaction to verify the signature. And this 35% reduction will obviously be very, very meaningful for such accounts. Obviously, alongside the general improvement for computation. So definitely stonks. This is on the computation front. There are also a few reductions on the data availability fronts. So today, if I am updating a single storage cell in Starknet, I am paying around 1K gas. Why am I paying around 1K gas? Because I am submitting the key, the location of what I'm updating, and the new value. Each of those is 32 bytes, and each byte costs on Ethereum 16 gas. So 32 times 16, I end up with 512 gas, so around 1K per a single storage update. 1K gas per a single storage update. But today we are not accounting for 0 bytes. which are cheaper on Ethereum. So we reduced some of the costs in an ad hoc manner. And this cost reduction will affect every single transaction. So every single transaction updates the nonce. When we update the nonce, we send a single 32 byte word that includes your new nonce, the number of storage updates in the contract, and the number of storage updates in the contract. So by saying, okay, assuming your account didn't do more than 16 million transactions and didn't update more than 64K storage slots, we can say both of these fit in at most 6 non-zero bytes. And this means we can, instead of charge the full 512 gas, only charge 200 gas. So this is around 300 gas reduction for every single contract that was updated. Every single contract that was updated, you'll pay less 300 gas for doing it. And for every transaction, you will pay 240 less gas because we'll charge less for updating your balance. So updating your balance, since we're using account abstraction, and your balance is just your regular balance inside an ERC20, it means that every single transaction has at least one storage update, which is your balance, because you are paying a bunch of fees, which means a minimal cost of 1K gas per transaction. And since, unless you're very, very rich, your balance does not exceed 12 non-zero bytes, we said, okay, the balance is at most 12 non-zero bytes, which means we can reduce 240 gas. So around 300 gas per every contract that you're updating will be saved, and 200 gas, 240 gas for every transaction will be saved. Any questions?
Let me check quickly. Yes, nothing so far about cost reduction, but I'm very excited about this. Computation is 50% cheaper, so that's really interesting to see. And yeah.
Yep, completely agree. One thing I didn't mention is, on top of these concrete reductions, there's a 10% off data availability cost. I feel like I'm in a supermarket. Data availability is 10% off only today, but throughout the version and from now on. The motivation for this reduction is that state diffs are squashed. So if you and I send different transactions within the same block that modify the same storage slot, we only have to send a single update to Ethereum. We're not paying twice. The sequencer does not pay twice to send those updates because we only send the newest value. But there is no after the fact reimbursement for the transactions that modified the storage cell. They do not share the costs as of yet. Maybe in the future we will have some mechanism that allows splitting the cost between those who participated in actually changing this, but today there is no after the fact reimbursement mechanism. So the simple way that empirically looked like it takes care of this scenario was to say, okay, overall 10% cost reduction for all data availability costs on top of the above fixed improvements. Yeah, so on the computation front, 50% cheaper. On the data availability, 10% cheaper plus some concrete 550 gas transactions for a single transfer, probably more for more complicated transactions because this addition gets repeated for every contract that you're upgrading. Okay, this essentially, yeah, this essentially sums up all the changes in 0.13. v3 transactions, paying with Starks, and cost reductions. Happy to answer any questions you or someone from the audience has.
Sure, let me check any questions regarding Starknet version 0.13. Well, from my end, I'm super excited for this update, mainly because it sets the stage for something even larger. And you discussed about this, that it sets the stage of the version 3 transaction, sets the stage for paymasters, fee market, volition. So it's a very important step. And I'm looking forward to the next versions. Let me see if from chat we have any questions. Everything seems to be good. It's mostly regarding something else. So I think we're good. Maybe if you have anything else to say, Ariel?
Not really, but as you saw, there are a lot of stuff in store. Probably a lot more cost reductions to be had, a lot more updates on the Cairo front. For example, we're starting to think about storage arrays and storage maps, which is something that has been requested for a while. Nicer loop syntax, a lot of news on the Cairo fronts as well. And eventually, this thing that I'm pointing at now, the L2 gas, will be very nice and a key step in the maturing of the ecosystem, where we actually consider pricing L2 block space and not only the L1 signature of the transaction.
Awesome. Great. I think then that's a wrap up. No questions regarding this version. So, Ariel, thank you once again for being here and for the presentation. I found the information about Starknet version 0.13 to be exceptionally valuable, and I hope our viewers feel the same. To our viewers, thank you for joining and tuning in into the 50th community call. Wishing everyone a fantastic day, happy holidays, and happy new year. And until next time, take care. Thank you, Ariel.
Thank you. Bye, everyone.